So today we're going to be looking at is different formats of quadratic equations. Okay, we have three separate formats that we're going to be looking at. We have standard form, factored form, and vertex form. And all of these forms we've seen in the last unit when we were solving and factoring in quadratics. Okay, so when we're doing all these things, there are 5 different things we can find for each format. We can find the vertex, we can find the x-intercepts, the y-intercept, the axis of symmetry, and whether it's concave up or down. And concavity just means, does the graph go up or does the graph go down? However, based on the fact that we're on a limited scale for this year, we're going to limit our scope of what we're finding for each one. So each one of these formats has specific things that are found easily because of how they're formatted, and some things that take a little more work. So we're going to take the things that are a little bit more work out of it, just find the parts that are pretty readily accessible. So let's start with the standard form. Again, although we can find the vertex and the x-intercepts, we're not going to use those things in their standard form equations. We're going to start off with just finding the y-intercept and the concavity. So for the y-intercept, a y-intercept is where a graph crosses the y-axis, and the y-axis is on where x is equal to 0. So if you put 0 in for the x's in your equations, a times 0 squared is 0, and b times 0 is 0. So all you're left with is the the y-intercept, which is c. This number is going to be your y-intercept, but we want to put it as a point. So we put 0, comma c. So whatever number c is, you put there for your y-intercept. Pretty simple. For concavity, we're looking at the a value. What is a? If a is a positive number, the graph's going to go up. If the a is a negative number, the graph's going to go down. Very simple. Okay, let's move on to the factored form. Again, you saw factored form a number of times when you factored your standard form equations in the last unit. You got factors. That's what factored form is. All right, so we're going to find the x-intercepts and the concavity in factored form. Now, one of the issues that I've always find students have with factored form and just solving it for x-intercepts is there are so many different names for x-intercepts. You can call them x-intercepts, they are solutions, they are roots, whatever it might be. Okay, so what we're going to do is take our factors, x minus r sub 1, and set it equal to 0, and x minus r sub 2, and again set it equal to 0. If we solve for both of these, we're going to get x is equal to r sub 1, and x is equal to r sub 2. Okay, so those are going to be your x-intercepts, but again, they are points, so we want to write them as points. So r sub 1, comma 0, and r sub 2, comma 0. Okay. For concavity, pretty simply again, what is a? If a is positive, the graph will go up. A is negative, the graph will go down. All right. The last one we have to look at is the vertex form. And so obviously if it's the vertex form, we can go and find the vertex because it's given to us basically. The vertex of this graph is going to be h, comma k. Okay, one thing you'll notice though, and this trips up many students, is the h value in the format is negative, but when it's in the vertex as a point, it is positive. Okay, so what you're going to do when you take that number out of your equation and make it part of your vertex, you're going to change the sign of h, and only h. K stays whatever it is. If k is negative, it's negative in the point. If k is positive, it's positive in the point. But h will change its sign when it comes out. It's basically the same reason why we change the signs for the roots in the factored form. Okay, when you take it out of the parentheses and solve for it, you're changing the sign. Okay. Next is the axis of symmetry. So the axis of symmetry is if you take a graph, there's our graph of a parabola, for example, and we draw an imaginary line straight through the graph to cut it in half evenly. There's our axis of symmetry, that red dashed line. Okay, well that red dashed line is a graph, or is it, yeah, it's a graph of a line. It's an x equals because it's a vertical line, and it goes through the x term of your vertex. So the x term of our vertex is h. So whatever h is going to be what x is equal to. Okay, so that's the dotted line equation. And then lastly is your concavity up and down. So again, we're looking at what is A. If A is positive, the graph's going to go up. If A is negative, the graph will go down. All right. So those are the things we're going to be looking for each of the different types of quadratic equations. Now let's do some examples of actually doing stuff. Okay, so here we have standard form equations. So we're going to put down standard because it looks like a standard form equation. Okay, and in a standard form equation, we're looking for two things. We're not looking for the vertex or the x-intercepts or the x-symmetry. We're just looking for the y-intercept and the concave up or down. Okay, so your y-intercept is again based off the last number right here. So that's 8. So our point would be 0, 8. And then concave up or down is going to be based off of the a value, and the a value in this case is negative. So it's going to go down. Now, based off the information that we have here for our equation, we want to sketch a graph. Now, it's not going to be perfect. It's just going to be based off of the information we have. So we do have a y-intercept, so we can put that down in our graph. So if our y-intercept is 0, 8, we'll put a point at 0, 8. All right, and it does go down, so we're just going to make it go down. We don't know where the vertex is. We're just going to draw a graph that's going to go down. So I'm going to put it like that. It fits the two things that we do know for sure. The y-intercept is 0, 8, and the graph is going down. We didn't find enough information to make it more accurate, so that's good enough. Okay. The next one. This looks like a factored form. Okay, and in a factored form, we are not looking for the vertex or the y-intercept or the x-symmetry. We're looking for the x-intercepts and the concave up or down. Okay. So for the x-intercepts, you're going to take each of the factors, x plus 2 and x minus 4, set them equal to 0, and solve. So x will equal -2 and x will equal +4. And we're going to use those as points now. So we have -2, 0 and 4, 0. All right, after doing the factors and finding the x-intercepts, we're going to do the concave up or down. Again, the a value in this case is negative, so it's going to go down. So now we go to our sketch. So we know the x-intercepts are at -2 and +4, so we put those points down. We know the graph is going to go down, so all we're going to do is make a parabola going through those 2 points. Where the y-intercept is, we're not sure about. We could find it if we really wanted to, but we don't. So we're going to just make our graph as accurate as a sketch as possible, and that's what it is. All right, last one we're going to look at. This is going to be a vertex because it's shaped in a vertex form. For the vertex, we're not looking for the x-intercepts or the y-intercepts, but we are looking for the vertex, the axis of symmetry, and the concave up or down. So when you're looking at your vertex, your h value is -1 inside the equation, so that means it's going to become +1 when it comes outside. And your k value is going to be +9. The sign doesn't switch, but for the h it does, the k it does not. The axis of symmetry can mean x is equals equation, and x will equal 1. Okay, the same value as your h. As for concave up or down, the a value is negative, so this is going to go down. Okay, so the vertex is 1, 9. So 1, 9 is going to be here, and we know the graph's going to go down, so we're just going to draw a graph going down. Okay, and that's it. We don't need to draw the axis of symmetry, it's just information we want. So that's good enough for now. Okay, so those are the 3 different formats and what we're looking for you guys to find. What I'd like you to do is try and do the rest of these problems as practice, and then we will see you later.